Hello, this is the significant digit video. I have put some shorthand notes on the board for determining whether or not something is a significant digit and what to do with the different mathematic operations. If you need these in more detail, they're on the PowerPoint, they should be in your notes. So, in general, significant digits have to do with how precise the measuring machine is that you're using, whether it's a measuring machine, I like that, whether it's a balance or a ruler or whatever it is. If you're the one taking the measurement, you know how many significant digits there are. But in chemistry and physics, a lot of times you're being given the data, and then you have to determine it so that when you do the math with those numbers, you know how to round. That's what the whole thing is, so that you can quit asking your teacher, what do I round to? So this is what we do. When we want to determine the number of significant digits, I'm going to run through these rules with an actual number. Let's pretend that this is a measurement. I don't know who took it, I just made it up. So we have 4,078, but then we got a whole lot of other stuff going on. So what we do is we run through the rules, and they're not like first do one, then do two, then do three. You might have to go back and check another rule out later. But the first thing that you have to be able to figure out is how many significant digits are present. Well, how many digits are there altogether? Digits are just numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8. Are all of them significant? That's what we have to figure out by going through the rules. So the first rule says if it's not a 0, it's significant. So the 4 and the 7, and the 8 are significant because they're not 0. An actual piece of instrumentation made that measurement. So there's at least 3. Second rule says if they're between significant digits, then they're significant. Well, that 0 is in between those two, so that makes it significant. Now we're up to 4. The third rule says, and this says two things it has to meet in order for it to be significant. At the end of the number, or the end of the value, to the right of the decimal. So here's the decimal. To the right, at the end, that 0 is significant. Well, now we got to go back, because the second rule said that if you were between, and it doesn't matter how many zeros are between, they're significant. So 1 and 2 and 3, so that has 8 significant digits. Let's try another one. 270 meters. We want to know how many significant digits. Well, following the rules, 2, 7, because they're not 0. Second rule says that there's a z. Keep in mind, the rest of the rules are for the zeros. The first rule is just for the numbers. So second rule says that if a 0 is in between significant digits, then it's significant. That 0 is not in between. Third rule says if it's at the end of the value, that's at the end of the value, to the right of the decimal. It's not to the right of the decimal. Here's the understood decimal. So that is it's at the end, but it's not to the right. So that is not significant. The fourth rule says if it just holds place value, and that's what that one's doing, it's holding place value. It's keeping 270 instead of 27. It's important for the amount, it's not important for the precision of the machine. So this only has 2 significant digits. Some other weird things that can happen, you can have scientific notation. Let's say that's a value, 3.2 times 10 to the negative 4th. Keep in mind, remember when we did scientific notation, these were pretty much just zeros somewhere. So you ignore them. And so when you want to figure out significant digits for scientific notation, you just look at the first factor and treat it like it's the only thing there. So a 3 and a 2, because they're not 0. And then this 0 here is to the right of the number, to the right of the decimal, and at the end of the number, so it counts. Try this one. Pause the video if you need to, and figure out how many significant digits. Okay, so this one has the 1, the 7, and the 4. And then that 0 is in between, and that 0 is in between, and this 0 is to the right of the number, to the right of the decimal at the end of the number. So that one has 6. That's how you figure it out. And the reason that we have to figure it out is for the second set of rules. This is what you do if you multiply and divide, and this is what you do if you add or subtract. So there are rules for when you do your math. Let's take 2.74 centimeters and multiply it by 0.06 centimeters. The first thing you do when you do the math is you do the math. So you're gonna need a calculator for this portion. You take 2.74 and you multiply it by 0.06. And when you do that, you get 0.1644. And then to be really technical, it's centimeters squared, because a centimeter times a centimeter is a centimeter squared. So this is what my calculator says. But for measurement purposes, I can't keep that many digits. For math, it's probably fine, but they're not taking measurements. So for multiplication and division, what you do is you look at everything that you've multiplied together or everything that you've divided, and you see how many significant digits each measurement has. So this one has 3. This one only has 1, because that 6 is not a 0. That 0 is just holding place value. It's to the right of the decimal, but it's not at the end of the number. So that's just holding place value. So my answer can only have 1 significant digit, because that's the least number. When you multiply and divide, your answer can have only the number of significant digits as the least precise. And so the least precise only has 1. That means that I can keep something in the 10ths place. So I look right next door, the 6 will change the 1. So the correct answer is 0.2 centimeters squared. And that's how you do multiplication and division. For addition and subtraction, a little bit different. First of all, you have to make sure that everything that you're adding together is in the same unit, or you're not allowed to add or subtract. But you do like you did before, you do the math. I probably do this in my head, but no. 0.06 plus 3.1. So when I add these 3 things up, my calculator tells me 4.9. And I have to see if that's correct or not for significant digits. So significant digits for addition and subtraction go by the least precise place value. So this first measurement is precise to the hundredths place. The second one is also precise to the hundredths place. But the last one is only precise to the 10ths place. So is my answer. And that's how it's gonna stay, because this is the least precise place value. So you have to be able to add and subtract and put your answer in the correct number of significant digits after you do the math. The hardest part sometimes is the rounding. So if we had something like 302.67, and you were told to round this to 3 significant digits, because that's what you had to do after you did the math, 3 significant digits means you can keep something here, and something there, and something there. So this 6 would change the 2 to 303. And that's how you would do that. So that's significant digits. If you have any more trouble, please come to tutoring on Wednesdays.